You gonna do it, or are you just gonna keep dry running it? You got this, man.
What's up, guys? Coming back to you here with another video. And you may recognize this place. About 3-4 videos back, we installed a laser here. This is Dickerson Industrial Services in Corinth, Mississippi. And this time it's going to be a press brake. I had some press brakes in stock, and they were like, hey, go ahead and bring us one. I'm like, all right, I can do it. So loaded up last Sunday morning and got up there in the evening, and then Monday morning they had a forklift delivered. This is a one from Sunbelt Reynolds. It's a Toyota 15K with 8-foot forks, and it's exactly what you need for this setup here.
At least it's tilting back now and not forward.
This is a 8-foot 110 metric ton or 120 US ton CNC press brake. It's a 2-axis with a programmable back gauge. It's actually an NC torsion bar style machine, and these are 42,500 delivered. If you want one, I've got one in stock ready to ship. So there's my advertisement for this video. Send me an email at the email address on the screen if you want one. So a couple of videos back, I delivered one of these down to a guy near Houston, and he actually used a crane to lift it off my truck or trailer. And so we had a crane scale there in the dash of the crane, and it said that this weighed 11,600. I've always been told, from the manufacturer that it was around 12,000, so kind of confirmed that. And you can kind of see by the way the forklift reacts and so forth that it's, it's a 15K forklift, and you couldn't really see it in the video, but the back end of the forklift was coming off the ground on the initial attempts where the brake was sort of away from the mast a little bit. But here you see coming around, driving the forklift around from the other side, coming in another door, and gonna get it up from the top. Right now it's sitting on cribbing in its final location. Come around and get the forks up on top and some rigging up there. Go ahead and lift it from the top, pull the cribbing out, get it down on the ground. These things do have jacking bolts for leveling it. We did not level it in this install. It'll run just fine with if it's not perfectly level, but it's best to go back and level it later. Here see Snoop up there getting things set up, and he's one of the main dudes there. You also see Tweet running around. He's the safety guy and the main CAD designer, laser operator. And then Todd's driving the forklift. He's let's say he's a boss man. So he's in charge, running the show, keeping it all organized. So this is one of the challenges in installing one in a smaller shop. You don't have the overhead to be able to get it from the top, so you kind of have to do some things from the bottom to be able to get it up and get the cribbing out and get it down on the ground. So this shop is like 110 wide by 220 long under clear span, engineered beams and all that. So they got, I don't remember the height on it, but it's probably at least 22 on the sides, or maybe 24 or something like that. And plenty of height to get above it. So pretty nice to be able to get it lifted up, get the cribbing out, and get on about getting it installed. right, so she's down on the ground where they wanted it, you know, squared up exactly where they wanted it to be. So next thing, get some hydraulic fluid in it. It takes around 40 to 45 gallons of number 46 hydraulic fluid. And here you see my man pouring it in there. Can't remember his name, but this is one big strong dude. And here's the tall man getting the electrical done. This is one of their guys that's I think out at one of their customer sites on a regular basis, but he came in to wire this one up. To look at a shop built press that they use on a pretty regular basis that they built I think a few years ago, and then an iron worker that they got there, and a betting bender. I think it was a 50 ton or 60 ton, something like that. Now go ahead and we're going to go ahead and get the holder moved over so it's generally lined up. So back off on this one. Same thing on the other side. It's like 2 inches to get it out of the way. So it's at like 878 now. Just touch the 878. 2 inches. All right, and hit your start. So the back gauge is out of the way. So go ahead and start down on the pedal. Looks like this needs to go in, doesn't it?
Down a little more?
Yeah, keep going. More?
Just down a little more?
Or loosen that one.
Huh?
Loosen it.
That's kind of decent right there.
Okay.
That down far enough?
It's far enough to be able to tell where it is. You good there?
I can come on down a little bit.
No, you're bottomed out there now. When you hear it starting to bind up, that's in the forming process, so it's at its depth. It's at its depth. And delete the step right there. Delete step. Yep. Now we're on step 1, so let's take it to 90 degrees. And 1.5.
Hang on.
There we go. And then hit start. So you can always just do a quick double check. So we got 188, we got our 3-inch wide, and then here we got a 1.5 inch die opening. Just double checking again. Now we're ready to make the first test bend. So we have our open bend, and we want to do our correction. So we're at about 97 degrees there. We know that scientifically by our perfect eye, right? And then start. So we're working up on it. We started off with this bend. Now we've corrected and we're there. Still got a little more to go. All right, remember the process to still underbent?
Mm-hmm.
Okay. So let's go to the 10, let's go 103. Really close on that one, huh? Maybe what, still a half a degree open or something? Let's measure it.
I don't want to be on the thing here.
Just show that way where I can, oh, there we go. Yeah.
See a good shot over right there?
All right, just showing you a look
That's
at
the way
some of
mine
the
is.
training and some of the process of dialing in a bend. And normally I can get, you know, a bend dialed in and corrected like in maybe one try, two at the very most. But I wanted them to see the process, you know, that you definitely don't want to get greedy and overcorrect and overbend. These dials are set up for a 90-degree bend, and if you get too aggressive, you can start breaking tooling. So it's definitely, when you're new, you want to sneak up on it, you know, leave it open, let it underbend, and work your way up to 90 instead of going way over and blowing out your, you know, die or something. So we moved over to the laser. Wanted to kind of show them also how they can use the laser to create their own tooling. So we're creating a laminated die. Tweet and I went into his office and designed up a profile for a 4-inch die opening, and then here we are. We already had some 3/16 up on the machine, so the laser just cutting that out. And I think we were using oxygen to cut that, but they normally cut that with air. And you know, air on 3/16 produces a little bit of a burr, so the oxygen always produces a smooth cut. And you can see kind of what we had in mind here. Use some threaded rod, and the laser is so accurate, and we had a very tight hole clearance that we ended up with a really nice fit up here. The main point of the exercise is just to show that, you know, for every little job, you don't have to run out and buy, you know, a couple $1,000s worth of tooling. You can whip it up, knock out your part. So here's a piece of 1/2 inch that we're bending in that 4-inch die, and you know, bend it with absolutely no problem at all. And we ended up with an angle that was just not quite 90 because we didn't get the angle on the die correct, but you know, you get the idea. So anyway, guys, that'll wrap up this video. See you on the next one.